see here. Trying to get my phone plugged up. It died on me. I forgot to call the decorated function. I was looking at it like in that last test case, and I'm like, this isn't getting called like at all because it didn't have pre.
LRU cache. LRU cache from the FuncTools module is an example of a decorator and an example of memoization. LRU cache memoizes the inputs and outputs of the decorated function in a size-restricted dictionary. It speeds up repeated calls to a slow function with the same inputs. For instance, if the function reads from disk, makes network requests, or requires a lot of computation, and it is used repeatedly with the same inputs. Here's an example from the Python documentation that perfectly illustrates how and why to use the LRU cache decorator.
Okay. Is that music a little too loud? I'm not sure. My is that much better? I try to I try to keep it under -40 on OBS. I just looked up and seen it was pushing up into like -25. I had a lot of fun in these 3 chapters. A lot of fun. Recursion was it was a challenge. It was. Mainly because I couldn't wrap my head around how the computer kept up with the current like result. But once I figured out what it was doing and how it kept up with it, it got a little bit easier for me. So I'm thinking about using a map, turning the word into a list, and then checking the first character against the last character, and then moving in by 1 on each side of that. Because I'm pretty sure a palindrome is like the first character, the last character matches is the same, and just so forth, right? So I really want to do it without a loop. Who said that? I've heard that before. Show me a recursive function and I'll show you where the bugs are. I've heard that before. I could actually do this recursively. It's probably, yeah. I mean, I need to because they're wanting me to figure out the base case. And plus this cache, I guess you use it with recursive functions. They're probably their test cases. Let's go look at the test cases. Probably what they're doing is they're feeding a bunch of words that's the same, like got the same letters, but adding on to it. Yeah, that's exactly what they're doing. So it's going to cache this, and only check these two. I think that's the way that works. I mean, from the example code over here, that's the way it looks. I've never used it before. This is my first time hearing of it. That's the I think that right there is probably one of the hardest things about teaching a STEM subject is finding actual application examples like math, like algebra, all kind like any kind of STEM. Finding an actual real world example and application to actually teach something. That that to me is seems like it would be very challenging if I had to like go out and teach somebody like how to program because most of the tutorials that you find. Yeah, that's actually a perfect solution, honestly. That's exactly what I was wanting to do too. I just didn't know how to structure it in code. That's like slows it down because it has to. I mean, I guess I see that. Yeah, but I see where you're coming from about the cache slows it down. In this example, but I see where it could be useful. I don't think it'd be useful in this example, but kind of like kind of like in manufacturing, because I was in welding and everybody's like, oh, you know, these robots are this and that, but oh, it takes a whole day to set up the robot, but you can let that robot run all night. So I could see where like if this function was going to get called a whole lot on a lot of the same kind of data or similar data, I could see how it could speed it up over the long term. But if this function is not going to get called that long, I could see where caching could slow it down because uh, it has to move data, it has to store data, it has to assign, like, the word has slipped my mind. It has to use memory, and that's a call. That's a CPU cycle. So I see that yes, it can slow it down. I'm actually that's the course that I'm taking right now in college is so I'm guessing that they want me to do this recursively because they mentioned base case and even the example code. Hold on, my son's calling me. He needs me. I'll be right back. All right, I'm back. I moved my laptop and like it come unplugged. Okay, so I know when I call this, okay, I don't think it needs to be recursive. There I am with the parentheses. It's because I'm having to do Java. Jumping back between having to do Java on my school project and Python and Boot.dev, I get the syntaxes kind of messed up sometimes. I'm going to try not to look back at your example that you put. know you divided that by 2, but yeah, I catch it like almost immediately when I do like mess up, and I'll like I was having to use the iterator in my school project, and uh I was trying to do a while loop without parentheses. I was like, why am I getting all these errors? And I'm like, oh, yeah, that is right. This has parentheses. Do I want to do? This is another thing that catches me in Python. I like the, I like that. I feel like this is going to give me an index error. Yeah, I forgot to that. You can't do that. I was mixing up a range. The string isn't iterable, is it? Yeah. So we'll do a range. Oh, I accidentally hit both of them with my pinky finger. It'll be out. Where did I get an error at? Out of range. Yeah. So I need a -1, then -I. This keyboard's killing me right now. Can't type. So 7 passed. Yeah, like I said that because I didn't want to take your solution. I wanted to figure it out and work through it. I mean, but that was the almost what you put in chat was like almost it was exactly what I wanted to do, but way faster because it cut computation down. It cut it in half essentially because when you divided it in half, And yeah, because it's essentially the same on both sides of the string. Okay, buddy. I mean, all these right here were optional, but I like doing the optional stuff. It like instills the learning. I kind of wanted to do like a map though. Use the map function. What are you doing, buddy? Yeah, it works both TVs because it's a Roku remote, man. No, I'm using the TV in here. I guess so, man. I'll move this down. Yeah, that's what I was wanting to do because this was functional, you know. I was wanting to use a lambda and pretty much do the condition that I did, but hold on before you turn this off. I got to pull this down, buddy.
Ooh, wow. This is awesome. Yeah, I watch now. Home.
Yeah, hit the home. Okay. I love you.
Because I I still I don't know. I still. Hello. What's that?
This is called Boot.dev, and this is Python code.
What is this?
It's a table of data.
Say it.
Say it.
Yeah.
Studies finance. Has trust fund. Has blue eyes.
Blue eyes.
Yeah. I think it's more lightweight too. I mean, can I have the chat? I guess not. I was wanting the chat. Just gonna minimize it all the time, you know. Yeah, turn that down a little bit, buddy. That's loud, man. Yeah. What is
Still those things.
all right? What are some types?
again? I didn't. Hey, yo, what is this?
It kind of sounds like generics a little bit. It sounds like generics that all derive from the same, that only take certain like types that derive from the same type. If that makes sense. No, maybe my assumption was wrong. I think this I think this fixes a problem that I was having when I was trying to implement a generic function, though, because in Java you can't check the data type of the passed in generic type at runtime in Java, apparently. What are you doing, my guy? Okay.
One. One. My legs.
Your legs hurt
Yeah.
all the time. What do you do, man?
What out of
Adeline threw a ball at you?
No, with my bones.
Your bones?
Yeah, push-ups.
Doing push ups?
Yeah, my bone hurt that thing. One, two, step in my shoe.
You have a good day at school today, buddy? No. Why not? Your friend hit you in the eye?
Yeah, look,
Yeah, I see.
I have a bully school.
You have a bully?
Two.
Okay, what do they want me to do here? My phone died and I had to turn it back on, make sure I didn't get nothing important. Dude, I need to check my grades. She still hasn't graded last week's assignments. I was really needing some feedback before I turned in these. No.
Dad, you work,
Say what?
work.
Yeah, I have to work tomorrow and then I'm off Sunday.
I mean, as a school.
No, you don't have school tomorrow. Mama's gonna watch you. Want to go to work?
You,
Hmm.
be a student.
Yeah, they even said that they're not part of Python. I guess. I guess because they don't have like an actual functional programming language course on here yet. I mean, even though isn't Python considered multi-paradigm to an extent? Brother, what are you doing? You're going crazy right now, man. Complete the parsed and parse error subclasses. Parse represents success.
Don't touch it. 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 You bad boy.
What?
You bad boy.
Nah. I love enums. turn this down.
Enums are one of the best things to happen to programming, and that's including the release of the best operating system of all time, Windows Vista. But before we talk about enums, let's brush up on a little bit of category theory. And despite the word theory being added to scare non-academics, it's really not too bad. In programming, types are how we categorize things. For example, this partner class contains two variables, both of which are Boolean types. So the partner type actually contains other types. And this is common when working with collection types like lists, tuples, and classes. The interesting thing about this partner class is that it really has 4 possible combinations of values. Studies finance can be true, as trust fund also true. Studies finance true, as trust fund false. Studies finance false, has trust fund true. Studies finance false, has trust fund false. And that seems manageable, but what happens if we add a third field? Well, if it's also a Boolean, then the number of possibilities actually jumps up to 8, because we have to multiply 4 by the available combinations again, which is 2, getting 8 possible total combinations. If we add another, we get 16, and if we go up to 5, then we get a total number of 32 combinations. And if we add a string into the mix instead of a Boolean, then the number of total possible values essentially goes up to infinity, because a string can contain any number of combinations of characters. Now, this is where the term product type and sum type come into play. They're also sometimes referred to as algebraic data types, just to scare the non-PhDs. The partner class is a product type because the total number of possible combinations of values is the product of the number of fields, right? 2 times 2 times 2 times 2 times 2, however many Boolean fields we had in there. But product types are very interesting. Almost everything is a product type by default. Lists, tuples, and classes with, a number of properties. And the problem is that product types result in many possibilities. And even primitive types like strings and integers have the same problem. When you have a string type, you don't know if that string value contains the entire text of the novel Moby Dick, or the string Hello World, or the empty string. There's so many possible combinations that could be stored in that type. And that makes them hard to work with, right? When you write a function that accepts one of those types as a parameter, you have endless if-else statements and switch cases and fallbacks to handle all of the different possibilities that could arise when your function is called with different values. That's where sum types come into play. They're just types where the number of possibilities is limited to a finite set. A Boolean is a good example of a sum type. It has 2 possibilities, true and false. When you're working with a Boolean, all you have to think about is whether this variable is true or false. Okay, so now we can finally talk about enums. Enums are another sum type, like a Boolean, and really I like to think about them as kind of extended Booleans. For example, let's say we want to write a button class, and in this button class, we want to specify that it can be one of 3 colors. We could have the button's constructor accept just a string to define which color it's going to be, and we'd accept either the string
Yes, just let me know when you're done.
red, the string green, or the string blue. Now, the problem is that our button class now needs to take into account that whoever's creating a new button could pass in any string, right? They could pass in the string teal, or they could just pass in a misspelled blue, and we need to handle both of those cases. The better option is to use an enum. And at least in Python, the way you can define an enum is using the enum package. You pass in the name of the enum, in our case, we'll use color, and then the possible values that are valid in this new type. So in our case, red, green, and blue. Now in our code, if we use color.red, it will work. It will resolve to the color red. And as far as the color type is concerned, everything will work smoothly. But if we try to use a color that was not specified when we created the color type, like teal, the Python interpreter itself will actually throw an error. So now the language itself will raise an exception if we ever try to use the wrong value. And that means that in all of our code, we no longer need to have all of these if-else statements checking and making sure that the variable maps to a valid value, right? There might be 10 different places in code that have to check the value, and we don't want to rewrite all that code. In a language like Python, The interpreter will yell at us when we run the code if we ever use an invalid value in an enum type. But in statically typed languages, like a lot of the compiled languages like Go or TypeScript or C, we'd actually get the errors either at compile time or even better, right in our editor telling us that those values are not allowed for that type. That said, enums are still useful even in a language like Python. Python's not statically typed, so it does mean we'll have to actually run the code to see the type errors, but at least the valid values, red, green, and blue, are defined when we create the enum type. So there's a single place to reference so we as developers can see what colors are valid types, and we won't have to keep redefining it every time we check the value.
Sometimes I hate autocomplete. Man, I don't think we're gonna make it.
Sum types. Unfortunately, Python does not support sum types as well as some of the other statically typed languages. Python does not enforce your types before your code runs. That's why we need this line here to raise an exception if a color is invalid. Def color to hex color. If color.green, return ff green. If color.blue, return header 000f. If color.red, return ff0ru. Handle the case where the color is invalid. Raise exception, unknown color. In a language like Rust, we could write the same thing like this. fn color to hex color color. Matter string, match color green 0 of ff to string. Color blue 0ff to string. Color red ff0 grow to string. Notice how there isn't any case for an unknown value. That's because the Rust code will fail to compile, a step that happens before the code runs at all, if the color is a different value. This static enforcement is a huge benefit of sum types, and it's a shame we can't get that in Python. match. Let's take another look at our example enum from the previous lesson. Color equals enum color, red, green, blue. Working with enums. Python has a match statement that tends to be a lot cleaner than a series of if-else-elif statements when we're working with a fixed set of possible values, like a sum type, or more specifically an enum. Def get hex color, match color, case color.red, return hefara.
I'll be right back. I have to. All right, I'm back. Let's see here. This plugged back up. Okay. wasn't for sure if I needed to do 5 or 6, and it was 5. So.
Export CSV. Doc2Doc should be able to prepare and export a CSV file of whatever data you input. Comma-separated values are a ubiquitous text format that allows for information to be structured in a table. There is usually a header row followed by data rows. Within rows, items are separated by commas. Assignment. Complete the getCSV status function. It should use a match case statement to select the correct response depending on the status of the export operation. Create functions to handle each operation as follows.
What do you mean, where TV remote at?
You had it.
I sold it.
Huh?
I sold it. I don't have it no more. I give it away.
No, you didn't, Dad. No, you didn't.
Yeah, I did too.
Where's Hamo?
Bro, don't be screaming, cuz.
Where's Hamo?
It's right here.
You lying.
I didn't lie.
Yeah, you did.
No, I went and picked it up. I told them that I needed a refund.
No, you didn't.
Or they wanted a refund. Okay.
$22, $23, $24, $25. 2, 4, 7, 8, 9, 10, 11, 12, 13.
Death on delivery.